Now let's simplify the following logical expressions. If we look at F1, which is A ANDed with A, then according to the idempotent law, this will give us A. So the answer for this is A. The reason for this, if A is 0, then 0 ANDed with 0 will be 0, which is A. If A is 1, 1 ANDed with 1 will also give us 1, which is also A. Let's move on to F2. If we look at the F2, A ANDed with A bar. So if A is 1, then A bar is 0, and vice versa. So 0 is always existent. According to the complement law, the answer here is 0. Let's look at F3. F3 equals to A ORed with 1. According to the identity law, the answer here is always 1. Whether A is 0 or 1, since we already have 1 here, and we are using the OR gate, represented by plus, then the answer is 1. If we look at F4, F4 equals to A ORed with A. According to the idempotent law, the answer will be always A. Think about it, if A is 0, 0 ORed with 0, the answer will be A, which is 0. And if A was 1, 1 ORed with 1, the answer is 1, which is A. F5 equals A plus not A, or A bar. The complement law here also applies. Here the answer will be always 1. Because if A is 0, then the A bar is 1. So the answer would be 1. And if A was 1, then A bar would be 0. But in any way, since we are using OR gate, so 1 ORed with 0 will be 1. So here the answer will be always 1. Let's look at F6. F6 equals to A ORed with A ANDed with B. This can be factored to get the following. A into 1 ORed with B. If we look at the 1 plus B, this is from the identity law. This is always 1. So we end up with A ANDed with 1. From the identity law, A ANDed with 1 is always A. And this is what we call the absorption law. Let's look at F7. F7 is A ORed with B. All of this ANDed with not A ORed with B. There's more than one way to deal with this. So if we write this here, F7, one way to go about this is to write the sum of the products. This equals now to equals A ANDed with A bar is 0. We proved this before in the F2. So we end up with 0 plus AB can stay, BA bar can stay, plus B ANDed with B. B ANDed with B is simply B. If we rearrange this, we end up with AB plus B plus BA bar. From the absorption law, this one is actually B. If you're not convinced, you can write it in the following way. Now this will lead to the same expression as the one above. A ORed with 1 is always 1, and 1 ANDed with B is always B, so I end up with B plus BA bar. This can be further expanded as B into 1 plus A bar. Now 1 ORed with A bar is 1. So here the answer is B ANDed with 1, which is always B. So F7 now equals to B. Let's solve F8. So F8 is A ANDed with A ORed with B. So if we write this as a sum of the products, we end up with AA plus AB. So this is the same as the above. A ANDed with A is always A. So I end up with A plus AB. Now this is the absorption law, which we proved before. We proved this here, which is equal to A into 1 ORed with B, or A ANDed with 1, which is A. So the answer for F8 is A. Let's do now F9. So F9 is A ORed with A bar B. This can be written as A plus A bar into A plus B. Expanding this will get the following: AA plus AB plus A bar A plus A bar B. Now, A ANDed with A, we know it's A. A bar ANDed with A, we know this is 0. So AB stays as is, plus A bar B. Now we know from the absorption law that A plus AB actually is A. So this is A plus A bar B, just to prove that this can be written as such. Now we prove that A ORed with A bar B can be represented with this. Then we can write further the following: A ORed with A bar is always 1, ANDed with A plus B. This can be written as such: 1 ANDed with A plus 1 ANDed with B. And the result is A plus B. So F9 now is A plus B. Now F10 is A XOR A. Now, in general, if you have A XOR B, the answer will be not A, B, ORed with A, not B. Now, we obtain this relation from the truth table. If you have an A and B, and consider putting all the alternatives, consider A and B with all the possibilities, then simply A XOR B is 0, 1, 1, 0. It's always 1 when you have odd numbers of 1. So this can be only true only when A is 0, that means not A, B, that's the case, or when A is 1, but B is 0, that means not B. And hence, this is how we derive this relation. So if we apply this relation in F10, we end up with A bar A plus A bar. A bar A is 0. And similarly, A bar is 0. So the answer is always 0 here. And if you wanted to double check this, you can draw the truth table for A XORed with A, and if A is 0, 0, 1, 1, so the answer will be always 0. So F10 will be always 0. Let's do the F11 now. F11 is the same as F10, but with an A bar. If we follow the same relation, we will end up with A bar plus we'll end up with A bar. This means it's going to be A bar plus A. A bar ended with A bar is always going to be A bar. And A ended with A is always going to be A. Now, A bar ORed with A is always going to be 1. Let's prove this by a truth table. And this is A bar. 0, 1, 1, 0. A XORed with A bar. Since the number of ones are odd in both cases, we end up with 1 in either case.